Today we are going to discuss on the numerical on the SAR. Now the first numerical to find the digital equivalent of V in is equal to 0.6 volt for 4-bit ADC and V difference is equal to 1 volt. Now first of all start from we take a register of the 4-bit and here we can consider and and this is the LSB and this is the MSB and we can name as V0, V1, V2 and V3. Now start from the MSB and the first step is for V3 and that is MSB. We calculated the V1 and V1 can be calculated by using the formula V1 is equal to V reference upon 2 to the power 1. Simply we can say that for the position of the B3 here the power of 2 is equal to 1. Now the V reference is equal to 1 volt. Now we get 1 upon 2 is equal to 0.5 volt. Now this 0.5 volt is compared with the 0.6 volt, and here we can see that the 0.6 volt means V in greater is the greater than V1, then the MSB value of resistor is 1. Now consider for 2 for v2 is equal to v1 means which is calculated from the first step v1 plus v reference upon, and here for b2 for b2 the power of 2 is 2, then v reference upon 2 is equal to 0.5 plus 1 upon 4 and we get 0.75 volt. And then this again compared with the b in, and here we can see that and v2 is greater than v in, then the resistor value is 0. Again for step 3 for v1, v3 is equal to v1 plus v reference upon 2 to the power 3 means 2 to the power 3 according to the position of the v1, and here v2 is not consider after v1 because the according to the v2 we get the resistor value 0, so it can't be considered. Then after solving we get 0.625, and here we can see that v3 is again greater than v in, then the resistor value is 0. Here we put the 0 in the b1 position of the resistor. Now for this step 4, that is for v0, v4 is equal to v1 plus v reference upon 2 to the power 4, 2 to the power the power is 4 because of the position of the LSB, and here the v2 and v3 is 0 because it gives the output is equal to 0, here 0 and here 0, and then b4 is equal to 0.5 plus 1 upon 6 is equal to 0.5 to 6 2. We get on comparison we get v in greater than b4, then the value of resistor is equal to 1. The finally we get the resistor value is equal to here 1001, and this is the binary value. Then in converted into the digital decimal value we get the value 9. Then we have to find the digital equivalent corresponding to this v in, and here we write the formula means v out means v out at the input of 0.6 volt is equal to v reference into input upon 2 to the power n is equal to v reference is equal to 1 volt, and input is equal to 9 volt from this conversion, and upon 2 to the power 4 means here, and here we take the SAR of the 4 bit, then after solving we get the value 0.5625. Now second numerical, what is the content of the SAR after the 3 clock pulse in a 5-bit successive approximation ADC with reference voltage of 1 volt if an input voltage of 0.67 volt. Here we calculate the content of the resistor after the 3 clock pulse means let us consider a register of the 5 bit and we put the value 10000, as we know that when we start the processing of the successive approximation register then MSB is always 1. Now for first cycle MSB is equal to 1, then SAR content is equal to 1 0 0 0 0. Then we find for this content of SAR, VDAC is equal to V reference upon 2 to the power 1 is equal to 1 upon 2 is equal to 0 0.5. Therefore, V in greater than VDC, then SAR unchanged. Unchanged means, and here we consider the SAR value 10000, then this value remains same when V in greater than VDC. Therefore, for this condition, means in cycle 1, for this condition SAR unchanged, means the value of SAR is equal to 10000. For cycle 2, SAR is equal to, let us consider the next bit is set and 11000, and VDC is equal to 0.5 plus V reference upon 2 to the power 2, means according to this bit we get 0.5 plus 1 upon 4 is equal to 0.75. Therefore, V in less than VDC, then here SAR changed. If this condition occur, then SAR change means, and here we consider the value 1, and then it can be converted to 0. Then the value of SAR is changed, that is 10000. Now third cycle SAR means that the third bit is set, means the SAR content is 10100. Then VDC calculated according to this content value is equal to 0.5 plus V reference upon 2 to the power 3, because here this bit position, the value of register is means the voltage at this position is equal to 0 is equal to 0.5 plus 1 upon 8 is equal to 0.625. Therefore, again compared with the V in, and here we can see that V in greater than VDC, then SAR is unchanged. Unchanged means and in the when they start from the cycle of the 3, and here we write SAR is equal to 100, and according to this condition SAR remain unchanged, then the value is equal to 10100. Therefore, SAR content after the 3 cycle, or 3 pulse is equal to 10100.